This is lecture 1 of Unit 2 for the Basic Chemical Engineering course, second year B.Tech Biotechnology at SRM Institute of Science and Technology. Unit 2 of Basic Chemical Engineering course deals with the concepts of mass balances in unit operations with and without chemical reaction. The unit operations without chemical reaction discussed are dryer, crystallizer, liquid-liquid extraction and mixer. A dryer is a unit operation where a wet material is dried by heating or sending hot air. In industrial, they use fluidious bed dryer or rotary drum dryer. In fluidious bed dryer, the wet materials are dried by sending hot air across the wet material, and the materials are fluidized through which the water content in the wet material is removed along with the hot air. In case of rotary drum dryer, there will be a rotating cylinder where the wet solids tumble and get dried by hot air. Dryer finds its application across various industries to dry the wet material. Mass balance in dryer involves equating the amount of input and the amount of output. In case of dryer, there is one stream is entering the dryer and there are two streams coming out of the dryer. So the feed mass is entering the dryer. There will be water vapor evaporated as a one stream, and there's another stream where a dry product will be collected. So in this case, to solve a drying problem, we will be expected to find mass of all the three streams. This slide depicts the process of drying. So in a drying, we will send the feed mass inside the dryer. So during drying process, water will be evaporated and that will be coming as one stream outside the system. And finally, we will collect a dried product. So in this case, if you see, there is one input to the dryer and there are two output streams from the dryer. So we name the input as M1, water evaporated as M2, and the dried product as M3. While performing mass balance in any unit operations, we will be equating the input stream and output stream. That would be the first step in solving the mass balance problem. In any problem solving related to dryer, we are expected to find the details of all these three streams. So coming to the feed, so the feed mass of feed entering the dryer, then the percentage of solids in the feed, percentage of water in the feed. In the stream M2, we are expected to calculate what is the mass of water vapor generated. When talking about the percentage of solid and water, that stream there is no possibility of solid to be present. So we can easily assume that the solid percentage is 0 in water evaporated stream and water percentage is 100 in this particular stream. Coming to the final product, that is dried product M3 stream, again we are expected to calculate what would be the mass of dried product after drying process and what would be the solid percentage and water percentage in the final product. While coming to problem solving in examination point of view, details of any one stream will be given and you will be asked to calculate the details of the other two streams. Let's start solving the problem so that we'll understand the concept in much better way. So let's read this question along with me. A batch tray dryer is used to dry 50 kg of wet solid to 5% wet basis. The initial moisture content was 40%. Calculate the amount of water evaporated and dried product. To solve the problem, first we have to list the given data. So we'll draw a schematic of dryer where one stream is entering, that is feed stream is entering, we name it as M1, and two streams are coming out, which is M2 and M3. M2 is the water evaporated. I already told you the solid percentage will be 0 in that stream, water percentage will be 100. And the other stream is final product, which is M3. So now let's see what are the details that are given in the question. A batch tray dryer is used to dry 50 kg of wet solid. In this case, the feed is 50 kg now. So I am assuming M1 is 50 kg. You can see I replaced it. Now let's proceed. And the initial water content is 40%. So the water content is 40% means the remaining will be 60%. So the solid percentage is 60. Now we are asked to reduce the water content to 5%. So the water percentage in final product is 5%. So the remaining must be solid. So it is 95%. So from the question, whatever the data is given to us, we filled everything. Now there are three stages we can solve the problem. First thing is we have to do overall mass balance. That is, we have to equate input and output streams. In this case, the input is M1 and the output two streams are there. So we are adding those two streams, M2 plus M3. So M1 is equal to M2 plus M3. Second step is to do individual balances for all the components. So I'm doing water balance. We take the overall mass balance equation and we multiply every term by the respective water percentage in that stream. Let's say in the M1 stream, the water percentage is 40%. So we have to replace this W percentage by 40%. That's what it means as water balance. So every respective stream will be multiplied by the respective water percentage in the question. That's why we are filling the data first. Now after water balance equation, we have to go for the solid balance. So again, you see here, every stream is multiplied by the respective solid percentage. So we write the overall mass balance, then we do water balance. Water balance is multiplying each stream by its respective water percentage. Then we do solid mass balance. The solid mass balance means multiplying every stream by its respective solid percentage. So let's see how to solve this. Now the overall mass balance. So in this question, M1 we already know. It is given in the question 50 kg. So I'm replacing M1 as 50 in this equation. But M2 and M3 we don't know. Now let's move on to next equation. So now in this equation, what is the water percentage of water in the M1 stream? This is the M1 stream. The water percentage in M1 stream is 40%. So I am just replacing the water percentage by the respective water percentage for each stream. So M1 stream is 40%, M2 stream is 100% water, M3 stream is 5% of water. So we replace. Now we'll move on to solid balance equation. Again, I am multiplying each term by its respective solid percentage. So M1 stream has how much solid percentage? M1 stream has 60 solid percentage. So I multiplied M1 by 60%. Then moving to M2, how much percentage of solid is in M2 percentage? The solid percentage in M2 stream is 0. So I am multiplying by 0%. Then M3, the M3 is 95%. So I am multiplied by 95% into M3. So you see the whole structure. M1 is equal to M2 plus M3, but we are just multiplying by the respective percentage of solid or water. For solving purpose, the percentage will be written in terms of fraction. So 40% means 40 by 100, which would be 0.4. 100% means 100 by 100, which would be 1. Now let's list out all the equations what we obtained so far. The first equation is M2 plus M3 is equal to 50. That is for overall mass balance. Then water balance equation is 0.4 into M1, which is equal to 1 into M2 plus 0.05 into M3. Similarly, we get the equation for solid mass balance also. Now in this case, you see in the first equation we have two unknown. In the second equation we have three unknown, M1, M2 and M3. But when we see the solid balance equation, M2 is becoming 0 because we are multiplying with 0%. So we are left out with only two variables. 0.6 times M1 is equal to 0.95 M3. Since the value of M1 is given in the question, I can substitute M1 as 50 and I can find M3 value. So M3 is coming to be 31.6 kg. Since I know M3 value, I can substitute here and I can find the M2 value. So the M2 plus 31.6 is equal to 50 and M2 would be 18.4 kg. Now we have found the amount of water evaporated and the dried product. Problem 2. A dryer processes 400 kg of wet solids at 50% moisture. During drying, 120 kg of water is removed. Find the final moisture content of the product. To do the mass balance and find the unknown, let's draw the schematic and then let's fill all the values which are given in the question. A dryer processes 400 kg of wet solid. So the feed is 400 kg in this problem and it has 50% of moisture. So since it has 50% of moisture, the remaining would be solid percentage. So I have written 50% of solid and 50% water. Now during drying, 120 kg of water is evaporated. So now the mass of the water evaporated, that is the M2 stream value is given. So M2 is equal to 120 kg. As I already discussed, in water evaporated M2 stream, the amount of water percentage would be 100 because only water vapor only will be present there. The solid will not be evaporated, so the solid percentage is 0, water percentage is 100. Now we are asked to find the final moisture content, that is the percentage of water in the product and also M3. Since both the values are non-known to us, we say the solid percentage as X and water percentage as 1 minus X. Now let's write the three equations. One is overall mass balance, water balance equation and solid balance equation. Overall mass balance is in dryer, there will be one stream is the input and two output streams are there. One is water evaporated stream and another is dried product stream. So M1 is equal to M2 plus M3 in case of dry air. Then water balance. So we are multiplying the water percentage in each stream with its mass. So M1 stream, the water percentage will be multiplied here. M2 stream, the corresponding water percentage. Similarly for M3 also. Now coming to solid balance again, the same mass balance equation M1 is equal to M2 plus M3, but each stream is multiplied by the respective solid percentage. So solid percentage in M1 stream, solid percentage in M2 stream, solid percentage in M3 stream. Let's replace the given data in this overall mass balance, water balance and solid balance equation. So M1 is known to us, it is 400 kg, so I have replaced that. M2 can be also replaced because it is given in the question as 120 kg. Coming to water balance equation, the water percentage in the M1 stream is 50%, so we are multiplying by 50%. In the M2 stream, the water percentage is 100, so I am multiplying by 100%. Coming to the stream M3, the water percentage is not known, but we assume that x and 1 minus x. You might have thought why we have used x and 1 minus x. Let's say the water percentage is 0.5. What would be the solid percentage? It would be 1 minus 0.5. That's why we have replaced as x and 1 minus x. In this case, you see, water percentage is given in the question. It is 50%. So what is the solid percentage? 50%. When I write it in fraction, it is 0.5. That's why I have written as x and 1 minus x. So coming back to the water balance equation, in the stream M3, the water percentage is represented by 1 minus x. So I have multiplied by 1 minus x. Coming to solid balance equation, I am multiplying the solid percentage of each stream. So M1 stream, the solid percentage is 50%. M2 stream, the solid percentage is 0. And M3 stream, it is x. Now we have this equation, let's try to solve. As usual, the percentage can be written in terms of fraction. So 50% means 0.5. Coming to the overall mass balance equation, M2 plus M3 is equal to 400. M2 is given in the question as 120 kg. Hence M3 would be 400 minus 120 kg, which is equal to 280 kg. So we have calculated the mass of the dried product. Now we have to find the x value, that is the percentage of water and percentage of solid in it. Let's take the water balance equation. So 0.5 into M1 is equal to 1 times M2 plus 1 minus x M3. In this equation, the value of M1 and M2 is given in the question. M3 we just calculated, so the only unknown is x. So when we rearrange that, we can find the 1 minus x value, which comes to be 0.286. The x value will be 1 minus 0.286, which is 0.714. So the solid percentage is 71.4% and the water percentage is 28.6 and the solid percentage is 71.4%.